Hello guys, welcome to my first set of A-level maths exam questions. Here we're looking at arithmetic, sequences and series. So if you download the questions, this page is in there too. Let's go. Alright then, first up, an arithmetic sequence is first term A and common difference D. The sum of the first 16 terms is 260. Part A, show that 4A add 30D is 65. Alright, so to do that, we're going to turn the sum into an equation. So we know the sum to 16 is 16 over 2, so 8. Lots of 2a add n minus 1d, so that's 15d. Now we know that that is 260. Alright, so at this point, both sides have a common factor of 4. So we can say then that 2 lots of 2a add 15d is equal to 65, and then expand the brackets. Go. Okay then, part B. Given that the sum of the first 60 terms is 315, find the sum of the first 41 terms. Alright, so we can do the same as we just did with the 60 terms. From that, we will then have two simultaneous equations, solve those for A and D, and then find the sum to 41. Alright, so the sum to 60 tells us 60 over 2, so 30. Times 2a and 59d is equal to 315. Alright, now both sides have a common factor of 15, so we get 2 lots of 2a and 59d is equal to 21. So 4a and 118d is equal to 21. Now we also know that 4a and 30d is equal to 65. Alright, So we now want to solve these two. Alright, now both of them have 4a, so we can get rid of a. So if we do a 1 minus 2, we are going to get 88d is equal to minus 44. So that tells us d is minus 1/2. Alright, now we're going to sub that into one of the equations. So I'm going to put it into number 2. So from that, we're going to get 4a minus 15 is 65. So 4a is 80, so a is 20. Alright, so now we know a and d. We can now find the sum to 41. So the sum to 41 is 41 over 2 times 2a, so 2 times 20 is 40, add n minus 1, so 40 times minus 1/2, so that's actually minus 20. Alright, so there we have 20.5 times 20. And that is 410. Given part C, Sn is the sum of the first n terms, explain why the value we found in part B is the maximum value of Sn. Alright, so what's happening in this sequence? The first term is 20, and then we're subtracting 1/2 to get from term to term. So the terms are decreasing. So let's work out what the 41st term is. So that's 20 plus n minus 1 times minus 1/2. So that's 40 times minus 1/2, so that's minus 20. So that is 0. So the 42nd term would be minus 1/2. So we should say something along the lines of, after the 41st term, every term is negative. So after this point, the sum decreases. And that's why the sum to 41 is the maximum value of Sn. Okay, number 2. So again, we have first term a common difference d. And this time, the sum of the first 36 terms is equal to the square of the sum of the first 6 terms. Part A, show that 4a add 70d is equal to 4a squared add 20ad add 25d squared. Good times. Alright, so we're going to find both of these sums and then use what we are told about them. So the sum to 36 is going to be 36 over 2, so 18, times 2a add 35d. Alright, now the sum to 6 is 6 over 2, so 3. Lots of 2a add 5d. Alright, so with both of these, let's expand in the brackets. So for the 36, we have 36a add 630d and then for the sum to 6 we have 6a add 15d. Alright, now we're going to put these into what we are told about them. So we know the sum to 36 is equal to the square of the sum to 6. So we're now going to square 6a add 15d. So that's going to give us 36a squared and then we're going to get 6a times 15d twice, so that's 180 AD. Add 225d squared. Alright, so now we would look for common factors, and luckily there is a common factor of 9. So divide through by 9 and we get 9a, no we don't, we get 4a add 70d is 4a squared plus 20ad plus 25d squared. Boom. be a tricky one. Given that the sixth term is 25, find the smallest possible value of a. Alright, so let's do what we can with the sixth term. So we know the nth term is a add n minus 1 d. So the sixth term is a plus 5d. And we know that is 25. Alright, so we're trying to find the smallest possible value of a. So we don't care about d. So what this allows us to do is find d in terms of a, and then we can, believe it or not, substitute that into what we did in part A. So from this, t is, well, we're going to subtract a and divide by 5. So d is 5 minus a over 5. Alright, so now we're gonna substitute that into the thing from part A. So let's do the sides separately. So the left hand side was 4a add 70d. So that's now 4a add 70 times 5 minus a over 5. So that's 4a plus 350 minus 14a. So that is 350 minus 10a. Alright, now we need to do in the right hand side. So the right hand side was 4a squared add 20ad. So that's now add 20a times 5 minus a over 5. And then add 25d squared, so that's 25 times 5 minus a over 5, squared. So that's 25. And then 5 times minus a over 5 is just minus a. So we get 2 of those. So there's a minus 2a. And then minus a over 5 times minus a over 5 is plus a squared over 25. Alright, so we have 4a squared add 100a and then 20a times minus a over 5 is minus 4a squared. Twenty-five times 25 is 625. 25 times minus 2a is minus 50a. And then 25 times a squared over 25 is just a squared. Alright, so we have 4a squared minus 4a squared, so they cancel. So we have 1a squared. And then we have 100a minus 50a, so that's 50a. And then we have the 625. Alright, so now let's put it together. So the left was 350 minus 10a. So we now know 350 minus 10a is equal to a squared. Add 58, add 625. Alright, so this is a quadratic, so we want everything on the same side equal to 0, so we can get 2a squared plus 60a and then take 350, so that's 275, and that is equal to 0. Right, so now we need to factorize that, so we need two numbers that multiply to 275 that add together to 60. So it's going to be something to do with a 5. So 5 times 50 is 250, so 5 times 55 is 275, and they add 260. Cool. So we get a plus 5 times a plus 55. So that tells us a is minus 5 or minus 55. So the smallest value of a is minus 55. A very tricky question. Final question, 3 consecutive terms of an arithmetic sequence are 3e to the minus b 5 and 3e to the b. We want to find possible values of b, giving our answers in exact forms. Alright, so because it's arithmetic, we know that 3e to the minus p plus d is 5, and we know that 5 add d is 3e to the b. Alright, so we want b, we don't care about d, so because they are simultaneous, we can get rid of d. So let's do one take 2. So that's going to give us 3e to the minus b minus 5, and on the right we get 5 minus 3e to the b. Alright, now we want to solve this for b. Now it's not obvious at all what we can do or what we don't want. We don't want a term with a negative power of b and a positive power of b. So to get around this, what we now do is multiply through by e to the p. So the reason for that is e to the minus b times e to the b is just 1. So we're going to get 3 minus 5e to the b is equal to 5e to the b minus 3e to the 2b. Alright, so this is now actually quadratic. So we're going to get everything on the same side. So we're going to move the right to the left. So we have 3e to the 2b minus 10e to the b and then add 3 is 0. Alright, Now, at this point, we can use substitution, which might make it look a bit less scary. So, what we can do, and we don't have to do this, we could say that, so we could let y be e to the p, and then that would mean y squared is e to the 2b. So we then have 3y squared minus 10y add 3 is 0. Alright, now factorize. So we're going to need a 3y and a y. Now, the numbers that are going to do it is a minus 3 in there, so that's going to get us minus 9y, and then a minus 1 in there, so that tells us y is 1/3, or y is 3. Now remember, y is e to the p, so e to the p is 1/3, or 3. So to get rid of the e, we log both sides. So p is log 1/3, or log 3. Alright guys, that's the end of this one. I really hope it's helped. I've got loads of these coming. Next up will be geometric sequences. Hope to see you there. Take it easy. Take care.